All right, so this is our condensing unit. Condensing coil, condenser fan motor, everything. I shut the power off. And one of the things that I want to do with this is I want to open up this panel like so. One screw here. One screw here. Panel comes off. Voila. I want to grab my meter. Where's this meter?
That's actually a California meter.
That's why it didn't work.
That's a cheap one. Don't set me up for it. Dang. Don't put me in the car for the DUI. Hop back in the front seat.
All right, so I'm going to check line 1 to line 2. I have 0 volts. I'm going to check line 1 to ground, 0 volts. I'm going to check line 2 to ground, 0 volts. So I'm safe to work on it. We're good to go. All right, so I'm going to work with this one. I think this is the size. Yep. So I'm going to take this top piece off. 1, 2.
Do you want the magnetic cord?
Sure. I want to pop this top piece here off. Right, if we see here, I'll lift it up so you guys can see it in just a second. Look at the table, please. First what I'm going to do is I'm going to pull this fan blade straight up so I don't damage the blade. These blades are very fragile, very thin. So if I lift it up, these are the mounting bolts at the very top. Now if I replace it with a universal motor, I'm going to want to put washers behind that to give it a good firm connection. But these are how this motor mounts. And if I pull this up, I can turn it like so. And now I can work with this motor just like this. I can get to everything, it's nice and secure. Need an adjustable wrench, please.
If you spin the fan, it might not come on.
It's what?
It might not accidentally come on.
Well, I checked voltage. Made sure all the voltage is off. I've shut voltage off and checked to make sure the voltage is off. Additionally, I can also lock this and tag it out so that nobody can turn it on. But residential, it's not required. But commercial, I definitely want to lock it out, tag it out. So here I got my set screw. I'm going to take my adjustable wrench and I'm going to loosen this set screw. All right, so there we go. And in this case, it drops straight down. If it was an old one out in the field and be rusted, I'd have to sand it, put the oil on there. And then what I would do is take the adjustable wrench, put it on the flat part, and work it back and forth, back and forth, back and forth till I got to right here. Oh my gosh, it's not going to work anymore. Oh my gosh, I put it on the other side. All right, back to business. Back and forth, back and forth, back and forth. Pull it right up. Notice where I'm holding it. I'm holding it on the hub. I'm not holding it on the fragile blade. I'm holding it here where it's steel. Now this one's metal, but it's still thin metal. A lot of these blades now, these blades are made of aluminum, or aluminium, right? They are very fragile. So people will take this motor out and be pulling this motor up and hitting the blades against the side, bending them all to hell. Or they'll take the motor out and just lay it on the ground with the motor on top of it. Any little bit of damage to this blade, and game over. This thing's spinning at 1,075 RPMs. It's no joke. It's moving fast, right? It is moving fast. Kind of like your ex-girlfriend was, moving fast. She's out. All right, so one of the things you want to check, especially with the aluminum ones, is right here where these rivets are. So here I got the heavier steel to the lighter steel, and we got the rivets. And if I was to pull a hair out, I don't want to pull one out because they're fewer than they used to be, and lay one across here, that's what a hairline fracture would look like. I don't know why they call it that, but that's what it would look like. And it just looks like a hair right there, but that's a crack. You need to say no to crack, right? So that'll start growing until eventually this blade will just end up ripping off in the air, and then this whole motor's doing this until finally the motor comes loose, breaks loose from the mounts, and chops to the side of the condensing unit, and all the refrigerant dumps out, and the compressor keeps running until it burns up, and then they got to have a new unit. It's not a good thing, right? So you want to make sure you take care of this blade. Even the aluminum ones, they really last a good while. It's usually when people damage it, or people do something, or people don't treat it right, and it causes a problem. A lot of people say, "Oh, I like the old blades. They were thick, heavy-duty metal." Well, that's one way to look at it, but thicker metal means it takes more energy from my motor and a stronger motor to spin that, which means more electricity. And when I'm looking at my air conditioner, looking at big, heavy metal, I'm looking at, let's see if we can get that thing to where it's saving me some money.
It's like watching your money fly away.
Yeah, exactly. Like automobiles, I want those old trucks built like a tank. Well, the old trucks, you'd have a wreck, and the truck would be in good shape, but you would go through the windshield, the steering wheel would go straight through your chest, or your body would slide forward, and the metal dashboards would cut your kneecaps off. That legitimately was an issue that they had. Now they have the cars that are lighter, more fuel efficient. Who didn't like? So many cars now it's like 40-something miles to the gallon. Yeah. Versus those old trucks that had like four. Yeah, exactly. And the other thing is now their cars made to crumple in a wreck to absorb that energy so that you survive. So just because things used to be heavy metal doesn't mean that it's always good. So we need to set this over there out the way so it doesn't get damaged on that table. Would be great. So here I have the motor. But what did I forget to do when I took this motor off? I didn't measure it. So that's going to be a real pain trying to put it back on. Right? So I take those two screws off on the bottom, those bolts off. This motor comes out. I undo the wiring. Here I got 3 wires. I got a purple one, a brown one, and a black one. What's the black one going to be? Common, all right. What's the brown one going to be? Start winding from the capacitor. Fan start. Brown goes to fan motor start. So if this one's common and this one's start, what's the purple one that's left over going to be? Run. It's the only thing left. It'll be run. Not run capacitor, run winding. Okay. And if I follow these 3, I'll find where they come in here. Here's the brown going to fan, which is the start winding of the capacitor. I'll have the purple one, which is connecting to the same leg that powers the run winding. And black is going to common at the contactor. All right? So now I need to put this fan blade back on and put it back together. If I had a longer shaft, it may be right there on top of that compressor putting a hole in it. So let's put that fan blade back on.
When you have your initial screw, it doesn't help you leave a mark so you can always find out where it is.
Well, in my case, I'm putting this same exact fan blade back on the same exact unit. So I can pull this off. I can look through that hole and make sure I line this hole up with that mark. But on your new motor you're putting in, it's not going to have that mark on it. It's going to be a flat shaft because it's never been used before. Another way to know if the supply house is giving you a used motor or not. You open it up, see if there's that little set screw in there. Somebody's installed it before. I don't want to put that motor in because what did they do wrong? Yeah, so these guys are slick. They'll dress it up real nice. So I should have measured it first. If somebody wants to get me a tape measure, I'll show you how to do that. But I'm going to put this back in the same exact spot.
When you put in the blades back there, should you always
Thank you.
put the screw on top and the blades below that?
Yes, the blade should be where you can access it. So let me answer his question for all you guys can see it. You hold that again? Yeah. Hold that. Hold that.
I was trying to get you, but you went all the way over there too.
See, gravity, that law is working, man. It's crazy.
Good thing they passed that law.
Oh, man, I tell you what. All right, so I definitely want the set screw to be over here where I can work with it. So if I had the set screw on this... Come on. This is such a pain to get in here. If I had the set screw like this, how am I going to get my adjust point in there to tighten it up? Plus the blades are turning backwards. Don't do that. I saw that once. Somebody actually did that. I'm like, here, take my hand and slap yourself with it. Yeah, no. So I definitely want this where I can get to it. So I'm going to put it in like so. And I'm going to take this out so I can see where I originally had it because I didn't measure it. Okay. Tighten that up like so. Get my adjustable wrench here. Tighten it up like so. Voila. I'm going to torque it down right there. All right. Now, if I was going to measure it, there's several ways I could measure it. I don't want to measure it from here. It's not going to do me any good at all. So I want to measure it from the base. So I'm going to go from the base. But notice that I'm kind of over here to the edge. So there's a few things I could do. I could measure from the corner of this blade where it comes in. But a better method would be if I put something across this, came over here to it like so. Let me turn it sideways, you guys can see it. So I got my blade, my tape measure here. I put this across. I can see where it lines up. Or I can do it on the bottom side if you wanted, if you have enough room. Okay, the bottom side's there, and I can see where it lines up. There's several ways of doing it. As long as however you did it, taken off, you do it that same way, put it back on. There's 100 ways to do it. I could do it like this, or I could do it from here on this part. You know, there's several ways you can use a level. You can use a level with a magnet on it. Use a straight edge. Whatever you use, just make sure you get a good accurate reading so your new one goes in that same spot. Questions?
You can measure from any point on the fan.
On where the fan mounts to, where it's mounting to. Not the fan itself, but where it's mounting to. In this case, it's mounting here.
But if you're measuring it from here, you could measure it from this blade or here.
Yep. Exactly. You know, as long as you're getting a measurement for this part that we're trying to reuse. That's correct. And you know what happens if you take this off and you run with it? You're a blade runner.
And the 1% chance when you can't lift off the blades and fix the whole thing, you just want to measure everything?
At that point, what I want to do is get the numbers off this motor, take my reciprocating saw, cut the shaft off right here. And that's a legitimate question. The only thing I'm going to take the supply house actually take in to measure up is going to be the fan blade. I will take and cut it. Now, there's a way to take it, and you can measure the pitch, and you can measure the length, the diameter of it, and the number of blades, and you can take that information in. But it's been my experience that there's little discrepancies between how companies do their measurements. So I found it to be on that location, clean the blade up, take it in, and you can line the new blade on top of it to make sure it fits. Wow. That's where I'm going to actually want to go to the supply house. And we don't change these often, but I want to, if it's a blade, I'm going to take this old one, go to the supply house, measure it up to make sure it fits the same angle. This is the pitch I'm talking about. Yeah. So this has got a pretty heavy pitch on it. Another one may be less of a pitch. That kind of stuff. I was going to say something else, but otherwise.
So you can't take it off, cut the shaft.
Yeah, I'm just going to take my reciprocating saw that goes back and forth, and I'm going to put that under here and just go and just chop that off. And now this whole piece with that shaft will still be there on it. Take it in the supply house. Oh, when you're cutting this blade, I got to say this. It's a shame I have to say this. Never use a torch to cut the shaft off. Yeah, because it's stupid. This is soft metal, so it'll warp. It bends it. It's turning at a fast speed. It melts the oil out of the bearings. It causes all kinds of problems. Plus, you can't get the blade on or off again after that. So it's just insanity. But I've seen that more than once. All right, now we see these wires aren't really lining up, right? They've got some space here. So what we can do is find the brown, black, and purple, and we can pull them over there on the other ends. As we pull them, just about got it. There you go. And it pulls it right up, and that conduit needs to be there. Oh, see how I did that? I hit the blades when I put it in. We want to make sure that conduit's there protecting that wire. I'm an honest man. I have to. All right, so screws. Anybody know where the screws went? Did we lose them? Where'd they go? Good job. So I want to put the screws on. We make sure that the top's nice and secure. Put the screws on. Now these top bolts, when you put the universal on them, will be a lot of times very tall. They'll be sticking up real high. After I get my bolts on there, I usually want to break that little excess off if I can. I don't want them sitting up here that high above these little jagged edges. And also, I want to do it like that so that when I put this fancy cover back on, ta-da, that they're not sitting through the top or just sitting on top of those 4 holes. I want to line this up, and this will actually, this should turn. Right, and voila, back together nice and clean. Now sometimes when you pop these off, those little plastic pieces in there will break. So if you take a little silicone, put a silicone in it, stick it back on, you're good to go. Okay? Now let's talk about these new motors, or these used motors. So we'll start with this one. A little bit of information we got to talk about with these motors. This is called your stator. It's because it's stationary. We call it the stator. And if you see in here these coils of wire, these are our poles. And we got separate sets of poles. Here, let's see. If we look at this, we'll have one of these is a thick. This one's a little bit different. So one of these sets of poles, forget it mixed up. One of these sets of poles is my run winding. 1, 2, 3, 4, 5, 6. The 6-pole motor. There's another set of poles offset between them. That's most likely going to be our start winding. So we got my run winding and my start winding that's in between it. And I also have 1, 2, 3, 4, 5, 6. Basically two separate motors. So this start winding is acting as a generator 1/60th of a second, and 1/60th of a second later it's acting as a boost to help the motor. Charge and discharge helps it through that winding. Does that make sense? Okay, so your run winding poles, and your start winding poles. This part here is called your rotor. It's because it, why is it? Oh yeah, it rotates. So this is rotating. Now this is actually inducing a magnetic field into this. So it's making this a magnet and then using this magnet to react against this magnet to make it turn. An inductive load inducing that magnetic field. So this is the motor that's open. Here's an example of a factory motor. We got red is going to be run, black is going to be common, and the brown is going to be start, the output of the run capacitor. And here I got red is going to be black is going to be start. Okay, so far so good. Here, that motor that you have, we have a plug. And there's 3 terminals in that plug. We'll have to find out one of those terminals is common, one of those terminals is start, the other terminal is run. Right, so here is a universal motor. And this motor was taken out. It actually ran. You can see how there's the oil and stuff on it. It's actually ran before. And somebody installed this motor. Remember we was talking about those little plugs to break off? Somebody didn't break them off. They took the time to bend it forward, but they didn't break them off. All you do is go back one more time, and it would probably snap right off. Actually, I'll show you an example. So they're already halfway there. Can't get it lined up real well. Let's go. Oh, this is not a hollow shaft nut driver. That's one reason. We need a hollow shaft. Where'd the other one go that I had? Here we go. All right, so if it just slides on here like so, and then I go back this way, and by the time I get right here, just like I said, comes right off. That's all I had to do. Look how clean that looks. Doesn't it look nice? Looks good, right? Not like this. Atrocity. Yeah. So now it comes all the way down. Now, if you notice here, there's oil around the sides. It's lubricated from factory for life, and that oil started coming out. It's overheated probably at one point. It started losing the oil, and if we turn this, it probably doesn't turn real smooth. You want to try turning it? Yeah. And this one turns nice and smooth. It also doesn't have oil around the sides. That one has oil around the ends, and notice it doesn't turn smooth. That one doesn't have oil around the end, and it turns nice and smooth. So a little bit of difference there. Now in the older days, we had to oil these motors. We had to go out every 6 months and put oil in it. And here where you see these little yellow plugs, this is where we put oil in. We had to open it up. We had to pop these plugs out. We had to take that Zoom spout brand oiler. It was real slick, and we had to squeeze a little bit, and it would pump the oil in here. And actually, there's a few drops, all it really needed. But here it had a piece of material that would soak the oil up and allow this to be lubricated. The new ones are oiled for life. You don't oil them at all. And I've seen people before that have these motors where the motor starts to seize up a little bit. And so what they'll do is they'll go take that oil and turn it up like this, and they put the oil in and let the oil soak into it, and then wait, a few hours, let its oil soak in, and then put it all back together where it's turning back the other way. And it works great for a week or two. And you're back out there. Just replace the motor, okay? Just replace the motor. They're not made to be rebuilt. They're made to be replaced. So you replace the motor. Don't go through all that waste of time.
So they don't got rebuilt.
Oh, we got 3 questions at once. No, we all knew. Drain plug. Great question. This one came from the factory that has 4 large drain plugs in it already. This one doesn't have one at all. And this one has 4 drain holes there already in it. This one's right here. There's actually, whoops, this one right here. It's still in there. Oh, nope, it's gone. There it is, right there. Just fell off the side. That drain plug on it is there. Can you look on that one? Okay, so there's your drain plug. Now if I look on this side of it, the drain plug's still in there on the top side, like it should be. The drain plug. There's one on this side, one on this side. There you go. That one's a nice clear one, easy to see, right there at the top. Now hold that motor up where everybody can see it. Hold it up higher, a little higher. All right, so what makes that motor look different? You can see the windings. There's holes in the casing of it. All right, that's what we call a church motor. It's holy, right? And because it's holy, that motor needs to be kept inside, away from the weather. This motor here is all sealed up where water can't get into it. It's the one that's made to go outside. Okay?
Is it really called a church motor?
You'll never know, will you? We do want to make sure we put the run capacitor with it. It'll for sure be a running joke. So we want to put that motor inside because it's not protected from the elements. This one's protected. This is what you call a semi-sealed or mostly sealed or enclosed motor. Where that one's an open motor where you can see all the windings.
So you can't.
All the indoor motors are like that. We pull the inside motor out of all these to look just like that. That's why this motor goes outside, that motor goes inside.
But you can never put this inside.
Could. Let's not devil there. Let's.
So I'm saying, like you said, you got a customer and you got to do something inside. You just.
Well, you got no choice. You stick it in there. Well,
If your amps and your volts and your RPMs and all that stuff match up, it's possible.
fractional horsepower.
It's possible. So understand the difference? When I'm talking about a condenser fan motor, these are condenser fan motors. That's what we call a blower motor because it's inside. Blower motor. Okay, so we'll put that one out the way because we're not going to talk about it right now. So factory motor, how many wires I got here? 3 wires. Good. Counting's getting better. Impressed. We're doing that wiring. I was getting concerned. Now we got this motor. How many wires I got on this one?
Too many. No.
Oh, 1. We're doing 1, 2, 3, 4. We got 4 wires right here, right? How many wires we got here? 3. How many wires I got here? 4. All right. So the black one's going to be what? Common. Here we got 2 brown ones. What did this brown one go to? Capacitor, right? Came from the capacitor. So what do you think this yellow one's going to be? So it's going to be common and run. Common and run. So one of these 2 are going to be start because it's brown. This one's start. It's brown. Brown's almost always going to the capacitor. But I got 2. Here's what they've done. They had problems with people not knowing that the same leg, whatever leg powers the run winding, also powers the capacitor. And the output of the capacitor powers the fan motor's start winding. People had trouble with that. Common goes to the opposite leg. They struggled really hard with that. I don't know why. They did. So the manufacturers of these motors said, oh, we're going to make it easier for these people. So what they did is said, okay, put this on one side of the contactor. Doesn't matter which side. Hopefully you put it with the other black wire. Put this one on the opposite side of the contactor, right? The opposite leg. And then here, these are your 2 browns. So you get a capacitor, the right capacitor with this motor. And this is where it gets tricky. You take 1 brown wire and put it on one side of the fan capacitor, and you take the other brown wire and you put it on the other side of that capacitor, and it's done. Now when I replace this motor, what else must I replace? The capacitor. That's a universal motor, so this capacitor that it needs is a 5 microfarad, 5370. It may be different from what that dual run capacitor was. And if my fan motor went out, does that mean that that capacitor for the compressor went out? No, I don't need to replace that dual run capacitor. I can simply add a capacitor just for this guy to work with. 1 brown wire on one side, 1 on the other side of a 5 microfarad capacitor, hopefully with the other common, and put this with the run, and it's already wired for me. That's it. It's pretty cool, huh? 1 brown wire on one side, 1 brown wire on the other side, and nothing else goes to that capacitor. Then this is common with the other commons at the contactor. And this is run with the other runs at the contactor, right? Sound good, huh? So why are there 2 brown wires, and which one is really and truly the start winding? Which one's the true start winding? The brown one. They're both brown.
One of them has a white stripe, no?
But one has a white stripe. One's brown and one's brown with a white stripe. Okay? The brown is the start winding. So really and truly, it's common, start, run. These are my 3 wires. What do we have here? We have common, start, and run. Right? So then what is this one with the mysterious wire with the white stripe? What leg powers the run winding? The run winding. What leg powers the capacitor? The same leg that powers the run winding. So of these legs, which one is the run winding? Yellow. This is my run winding. So that means this leg has to power my what? Capacitor. So this one with the white stripe is the same thing as this yellow wire. This is my run winding. The same leg that powers the run winding goes into the motor. They pull it back out to idiot-proof it. This is still the run winding. The same leg that powers the run winding also powers my capacitor. The output of the capacitor powers my start winding. Common's on the other side. So technically I could take this one with the white stripe and cut it off and still I'd have my 3 wires like normal. But since I got to replace the capacitor anyways, one on one side of the capacitor, one on the other, one on one side of the contactor, one on the other. Does that make sense? Right? So all universal motors are going to be like this, not like this. OEM motor, if I have the luxury of going to the factory and getting it, they're going to give me this exact motor, the right size shaft, everything's good. But my universal, I'm going to have this set up. So it's very important you guys know what that means, what it hooks to. Does that make sense? All right, now, the other wires that I was hiding from you, trying to, are these wires here. What do you think these are? This motor came from the factory turning in one direction only. Another motor may turn the opposite direction with the exact same numbers. My universal motor made to go either way. I can make it go this way or make it go that way.
Standard diode?
What's that?
Standard diode?
Nope, it's just how they wired inside. We're switching between which way the commons connect on it. So what's cool about this is I can unplug this, turn it, and plug it back in, and the motor will turn the opposite direction. How cool is that? So what we're going to do is we're going to look at this and see which way it's turning. It says if I connect black on black and white on white, that it's going to turn CCW. What does CCW mean? Counterclockwise. C, counter, C, clock, W, wise. Counterclockwise. All right, so let's explore this for a second. Here's my motor. I'm going to hold it and I'm going to spin the motor. So I'm just going to stand over here so everybody can see me, right? Let's do it like this. Which way is this motor turning? Okay, everybody agree? Everybody agree. Okay. Which way is this motor turning? Which way is this motor turning?
Clockwise.
Which way is this motor turning? Huh, so it's all in your perspective, huh?
Yeah.
It's all in your perspective. So, which brings another point to it, right? It's like, oh, I'm poor. You go to another country, wow, I'm rich. You still have the same amount of money, right? It's still turning the same way. It's all on how you look at it. So, these are leads. Right? They're basically leads are just wires, but they're leads. The leads are mounted on this end, like the butt end of the motor usually. So this motor actually says black on black, white on white is CCW, counterclockwise, LE, lead end. So that means if I have it hooked up black on black, white on white, this motor will turn counterclockwise looking at the wire end, the lead end. That means it's turning, if I'm looking at it this end, it's turning this direction. If I look at it on that end, it's turning the opposite direction, right? So most motors use LE, lead end. So now I can, if I know which way that blade is pitched, I can set my new motor up to turn the correct way before I ever hook it up in there. If I look at the pitch of the motor, I got to say, okay, this motor's looking at lead end. I'm going to set it up lead end, and then I'm going to go ahead and, there we go, we're set to go. Or I look at it and think, oh, no, it needs to be turning the other way. I will then take my wires, unplug them, and plug them back in, and now it's going to turn the correct way, whatever way it needs to be. Now it's going to turn clockwise, lead end. Lead end. Follow me?
Yep.
So far, so good? Pretty cool. They put that little reversal on there, huh?
So what does it say other than lead?
Ooh. Why you got to be complicated for? And the answer is because manufacturers got to be complicated. That's why. let's take a look at this Basco motor. Basco motor says we're going to turn CCW, and we're connecting yellow to purple and purple to yellow. So here I got yellow to yellow, yellow. So I'm going to switch these and make it turn that other direction. So I'm going to switch these with these and these to these. So now I'm connecting yellow to purple, purple to yellow. So now I'm connected CCW, counterclockwise, shaft in, or something that just says SE. So now that means this is going to turn counterclockwise, looking at it from this way. So if I need to use it looking at it the other way, I have to do it's always going to be the opposite. I don't make these rules up.
I totally screw up the airflow.
Oh, you got to make sure it's turning the right way. In the end result, you just got to make sure it's turning the right way. Okay? So some of the motors use lead ends, looking at it from the butt of the motor. Others like to look at it from the shaft. They call it shaft end. You can look at it from how you want to look at it. You just got to convert how they look at it to the other side. This motor likes looking at the butt. This motor's looking at the shaft. It's how they look at it, but it still didn't change the motor. You want to make TMI. It just needs to serve how that blade works, right? Even if you're looking at this end, there's still a shaft on it. So you know, it's 2018 now, so it's okay. It's okay. There's nothing wrong with it. We all want to support you, and it's going to support you from this side of the table. That's all. Okay. So, as if that's not enough, though, there's another motor manufacturer out there that calls it OSE. Opposite shaft ends. So you have lead ends, you have shaft end, and you have opposite lead end, which is the same thing, or opposite shaft end, which is the same thing as lead end. All right, but the moral of the story is a universal motor is reversible. The catch is, you want to make sure that blade's turning the correct way. If the blade's not turning the correct way, it's not moving in the air. If it's not moving in the air, you're not going to reject any heat. Not rejecting any heat. The compressor's going to overheat. The compressor's going to overheat, trip on internal overload, internal safety, or internal bypass. And it's going to damage the compressor. Okay, so it's a big problem. So, moving forward. When we take this old one out and put the new one in, I want to make sure these new wires run through that conduit. And if there was never conduit there, I want to go get some conduit. A piece of PVC will work as conduit. I can also will always have, see that grate coming from that disconnect box? We always have that on our truck. Always little pieces left over. And it just so happens, all it needs is a little piece to make this happen. I can put it in, even if there's no way for it to hook, I can run it across the unit and use cable ties around that to the top of the unit, and I can take these cable ties and hold them in nice and secure. That's okay as well. Don't use clear or white cable ties. They can't handle the sun and the heat. You need to use the black cable ties. They work better, right? They're not going to break down in the sun. Right? So, one more thing while we're talking about that. Here, my reversible wires are right here by this. I can most likely take this and push this up inside that conduit. I'm going to be okay. This one, I can probably do that same thing. I can push it up inside the conduit. It's going to be okay. Let's see this motor over here. This motor, my leads are over here, but my reversing wire is on the opposite side. So in this case, I'm going to need to take a little piece of conduit and slip it right inside of here, use my cable ties, and cable tie that piece of conduit to the top. So that way they're nice and secure. Does that make sense? That way they're nice and secure. Worst case scenario, if you don't have any conduit at all, you can put electrical tape. I don't like it, but you can put electrical tape on this, and you can cable tie it to the underside of the fan as well. And you could also do that with this, I guess, but you really want to use conduit. So it's there for it. Conduit's made to protect the wires. It's a really nice, easy thing to do. So far, so good. Okay, now, let's talk about what we don't want to do. Oh, well, one more thing about what we're doing. Let's say that you get the counterclockwise, clockwise, shaft in, opposite shaft in, lead in, all those mixed up, which is legit, right? I mean, it can happen. I can go ahead and hook my motor up, run my wires in, get everything done, and just leave those 4 screws on the very, very top, leave them loose. Wow. Then I can have it hooked up, I can power the unit on, and take a pencil or an insulated screwdriver and just tap the contactor. A little tap, tap, little tap, 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 little go to your home, little tap, little tappy tap, right? Little tap in there, and that's going to give the motor just enough energy for it to barely, barely turn. And you can see, as it's turning slow, which way it's turning. And if it's turning the wrong way, you can lift it up, lift that little piece up, reach in there, reverse it, put the cover back on, cable tie it, put the screws on, and you're good to go. It's not hard, right? Worst case scenario, just don't secure the wires, lift it up, and if it's turning the right way, lift it up and then secure them. If it's turning the wrong way, lift it up, reverse them, then secure them. It's that simple. Anybody have a hard time with that? Does that make sense? Yes. I lift it up. It makes a hard time? I'll explain it again. We're going to make sure this wire is covered and protected. However long that takes you. Now, what you don't want to do. Well, I can't understand clockwise and counterclockwise, and I don't want to do all this work, so I'm going to put this to the top of the unit, and it's 280, 208, 230 volt. I'm just going to put this to the top of the unit over here, and yeah. And that way I can hook everything up, and if it turns wrong, then I can just go to the top of the unit and flip the wires, and then turn the right way. Don't do that. Who thinks that's a good idea? Good answer. Here's the problem with that. This unit hasn't been protected. Look how the sun has eaten this plastic all away. The plastic, now there's bare metal showing. Here's one problem. The bare metal touches and arcs and shorts out, could cause a fire even. Most likely it's going to arc out, short out, cause a bigger problem. Another issue is that unit, let's think of an apartment complex where there's a bunch of these units down low. And let's think of an apartment complex, there's always that neighborhood kids that run around and playing on the carts and running down the street. You almost run over them as they're running across the street. They're kids. They don't know better. They're having fun, right? That's why you go slow in apartment complexes. That's why you don't do burnouts in apartment complexes, like some people in this town do, right? It's kids playing. Kids don't know any better. They're learning. So kids see this unit here running, and they see that fan, they see air coming out of it, and it's interesting to them, right? They walk over, and now there's wires sticking out to the top that's been sunbeaten. And they go, oh, what is this? And kids have been electrocuted, have been killed before because these wires are sticking to the top and exposed. And the metal ground, and they touch it, 208 volts going through their body, and their bodies are small. They have very little resistance, which means fast amp flow, and their hearts can't take much, and they die. How would you feel because you were too lazy to lift it back up, not put the screws in it, lift it back up to switch two wires and put a piece of conduit on it, versus you took away somebody's child? Does anybody here have kids? Imagine if some service technician did that and your kids died because that guy did that. Your kids died because of that. Or if you don't have kids, if you have cats and their cats touched it and they died because of that. I mean, it's a bad deal, right? Right? It's a bad deal. Now, the other thing is, these are old and worn, but what if these wires were new? They'd be bright and shiny, like ooh, bright yellow, bright purple, bright colors, right? So even if these weren't corroded up like that, oh look, bright stuff I can play with. Well, what does this do? It kills you. They're dead. They're dead. What happens to your career? Over. Good chance you're going to be in jail time on that one. That's probably kind of like manslaughter stuff there somehow. You start messing with somebody's kid, it's not good. So it would obviously you would think wires sticking out through the top unit's not a good idea. These are small wires because they're made to be inside a conduit. They're not made to be sitting up. Do you see Romex wire running on the outside of houses? That's only 110 volt. Plus there's insulation, another piece of insulation, a grounding wire with it, and another piece of insulation on the outside of it. This doesn't have any of that. It's just a thin wire. And imagine 208 volts, twice the voltage, exposure so somebody can get to it. Why would anybody ever in their right mind stick this above it? Why? I have no idea. It's absolute and freaking insanity. Don't you ever, even if it's on a roof. If it's on a roof, you still don't do that. I've had before, well, it's on the roof. So, you don't do your job because it's on a roof? Right? What the hell? You're in another state, you don't wipe? I mean, what the hell's going on? No, you still do it. Still a thing. Protect those wires out of the way. Right? Do not ever leave those wires sticking out to the top. Ever. I really don't have a problem if it's an apartment complex. Not that I've ever done this, but I wouldn't have a problem taking my cutters and cutting them all off where nobody could get electrocuted.
You want to come over to my apartment complex and do that?
I don't, because that'd probably be considered some kind of vandalism, but I would rather that than somebody getting electrocuted for that. The hard part is trying to tell apartment complexes about it. The last complex I was at, I was trying to tell them, hey, look, you can't have those wires sticking out. Somebody's going to electrocute it. Or our rotating maintenance guy knows what he's doing. Okay, let me talk to your lawyer and ask him, whoever, and your insurance company both, there's wires exposed where kids can play with it. And let's see if they say that's okay. They're going to be like, what? I have gone as far before, though, as take these pictures, write up or have articles attached to it, and write this up, and who I talked to the maintenance company, and sent this to the head maintenance, the corporate thing about what's going on. And when you send it, and also send it a certified letter, because when you send a certified letter, it says it's like a whole other level of seriousness. And it's amazing how quick some of those things will get fixed. And it's funny how your local maintenance guy that, we know what we're doing, is not there anymore. And the people in the office you talk to, the managers in the office, aren't there anymore either. Because it's a big deal. Yeah. It's a big deal. It's a really big deal. Never let those wires be exposed. People die. You can't have somebody die. Now something else that's less important, but still kind of a thing. This motor is metal. Mounts with metal screws to the metal top, through screws to the metal casing that the ground wire is attached to, which goes to the metal ground. So it's metal to metal to metal to metal. Do you need a ground screw in this? Yes. No. That one doesn't have a ground screw. It's metal to metal to metal to metal to metal. It grounds through metal. If the motor's to ground out, it immediately shorts out. None of these motors you look at have a ground wire on it because they are automatically grounded. The universal motor, though, doesn't know what you're hooking it up to. So they install here a green ground wire. And if you notice, this ground wire is mounted right here to the case of the unit. If I mount this to that, I don't need this ground wire. I'm going to cut it off. They're like, you can't cut the ground wire off. Where's the ground wire on that one? On that one, on any of them, they don't have it because it's metal to metal to metal to metal to metal. And I'm mounting it metal to metal to metal to metal to metal. I'm going to cut this thing off because it's going to look a lot better and cleaner. I see other people that take this ground screw, circle it right back on itself, and put it right back into where they're mounting it. And it's like, blow it in the wind. Or they'll stick it to the top so the fan blade doesn't hit it. Won't hurt anybody if it does it, but it just looks ridiculous. And you're putting it right back to where it is. It's not going to do nothing. And if you really wanted to be serious about using it, you'd have to extend it because it's not nearly as long as the other wires and hook it to the actual ground screw. But I mean, it's still not going to do anything different. Now, let me clarify. Some motors are belly band mounts, which means it mounts right here. And there's 4 or 3 prongs that come out, and it mounts to the top through rubber grommets to absorb vibration. It just so happens that rubber doesn't absorb allow electricity to flow so well. So if the motor shorted out, it wouldn't short to the frame and it wouldn't trip a breaker. If you have rubber mounting grommets on it, like blower motors almost always have a ground screw because there's rubber from when they stop making them quieter. If you have rubber mounts on it, then yes, you're going to need to run the ground screw. If the motor, basically here's to make it easy. If the motor you have has a ground screw hooked up to some place in a different location, then use the new one. If it doesn't have one, then you mount it the same way, you're going to be okay. If the old one had one that came out and right back on itself, it's not doing anything. It really isn't. All right? Any questions? Okay, we've covered a lot of information, so now I have an assignment for you guys. So what we're going to do is we're going to go to all of these units, and you're going to write down what information, not just the information that we need to change the motor, but if it's a commercial unit, the frame size, the volts, the amps, and also we need to write down the capacitor size of that motor. So you get used to seeing where that is. Not just on these, but also on these on the table as well. And that's probably enough. So let's get started with that. After we do that, I have another assignment we're going to do. And go.